30-day data science challenge. We're going to go over some SQL stuff here. So we're going to go over day 4, which is sorting data with order by, and we'll explore the order by clause, which is used to sort data in ascending or descending order. Sorting is a crucial aspect of data retrieval that helps organize and analyze data effectively. So let's get started. So we'll go over what is the order by clause, basic syntax of order by, sorting in ascending order, sorting in descending order, sorting by multiple columns, and practice and summary. So what is this clause? It's used to sort the rows returned by query based on one or more columns. And by default, it's sorted in ascending order unless specified otherwise. So you have the syntax, you have to select the 2 columns from the table and you order this specific name, and you have it in ascending or descending. Column name is the column you want to sort by. Ascending is the optional keyword in ascending order for default, and descending is the keyword to sort in descending order. So if you sort in ascending order, use ASC, and it arranges data from smallest to largest for numbers or alphabets for strings. So if you have this employee table, you basically sort the employees by age in ascending order from select star from employees and then order by age. And then you also have sorting in descending order, which arranges data from largest to smallest for numbers or reverse alphabetical order. And we can sort the employees by age in descending order here. So you select star from employees and order by and do descending. And you can also sort by multiple columns. So you can sort by these columns by specifying them in the order by clause. Sorting is applied in the order the columns are listed. So you can sort employees by department in ascending order and age in descending order. And this is what you can see here. And then there's some practical exercises, like you can retrieve all rows from employees table and sort by name. You can sort the employees table by department in descending order. You can combine sorting by age in ascending order and department in alphabetical order. You can create a query to sort a new table products by price in descending order and stock quantity in ascending order. And this basically shows how to use the order by clause to sort data and the sorting data in ascending and descending orders, and then how to sort by multiple columns for complex queries. Then you can practice these concepts to solidify understanding. And tomorrow we'll dive into aggregate functions and grouping data with GroupBy. So we're going to move to that lesson now. How do you use aggregate functions and the GroupBy function? So we'll go over what are aggregate functions, common aggregate functions, GroupBy, combining GroupBy with aggregate functions, practice exercise, and summary. So aggregate functions are used to perform calculations on a set of values, returning a single value as a result. These functions are commonly used to summarize data in SQL, and you basically have the count function, the sum function, average, min, and then max. You can select count as total employees and average salary as average salary from employees. So it's selecting all the count as this variable and then the salary. You can use GroupBy as well. This is used to group rows that have the same values in specified columns. It's often used with aggregate functions to group the results by one or more columns. So you can select the column 1 with the aggregate function column 2 from the table and group by this column. And then you can imagine the following table here. You select the department, can sum the salaries, total salary from the employees, and then group by department again. And then you basically have this result outputted. You can combine with other aggregate functions, so count, average, max. Whenever you see the as, that's basically how the aggregate function is working. So count as the total employee, average salary is average salary, and then max salary is the highest salary from employees. And then we have the group by clause over here, so it's specifying by department. You can write queries to find the total number of students in each course from the student table, calculate the salary, find min, max, and count number of orders. So that's the practical exercises when we went over aggregate functions and how to use them, and the purpose and syntax of the GroupBy clause and how to combine GroupBy. And then we'll be going over the have clause here. So let's go over the have clause, and this is day 6. So it's an essential tool for filtering group data in SQL. So let's dive into syntax and applications. So what is the having clause? The having clause is used to filter the results of groups created by the GroupBy clause, unlike the where clause, which filters rows before grouping. Having filters groups after aggregation. So syntax of having, you basically have select column 1, column 2, and then aggregate function of column 3 from the table name. Group by the 2 columns and have a certain condition. So that's important. So aggregate functions, as we saw before, were sum, average, count. And then we have this condition to filter the group data. So the where clause filters rows before grouping. The have clause filters groups after aggregation. In the where clause, you can't use aggregate functions directly. In the having clause, you can work with aggregate functions. In the where clause, you have age over 30. In the having clause, you have count star greater than 5. So examples of the having clause, you have basic usage of having. Suppose you have table name sales. Define regions with total sales greater than 10K. We have select region, sum the sales amount as total sales from sales table, group by the region, and then have the total sales greater than 10,000. So it's giving us this condition. This is the result. So none of the regions have sales greater than 10,000. So the criteria has no rows, as we can see there. In example 2, you can have multiple conditions. So to find salespersons who have made more than one sale and whose total sales exceed 6,000, we can have this select salesperson, count star, sales count, sum the sales amount is total sales from sales, group by salesperson, has sales count greater than 1, and total sales greater than 6,000. Then we have these two columns here. In example 3, you have combining having with other aggregates to find regions where the average sales amount is greater than 4,000. We have the select region, average sales amount is average sales from sales, group by region, having average sales greater than 4,000 gives us this result. So all the sales are greater than 4,000, they're grouped by the region from this table, and there's an average amount. You can also do having with counts. So if there's a student table, you have select class with count of student name and student count. From students, group by class, having a student count greater than 2. So wherever has student count greater than 2, it'll look for that specific class, and it's only class A, which has 3 students. There's some practical exercises. You can see a table of orders with columns, customer ID, order date, order total. You can use the having clause to filter products from the products table, modify the examples above to include additional conditions or aggregate functions. You can create a query for a library table to find authors with more than published books. And we basically went over the having clause and how it differs from where, and writing queries with having to filter aggregate data. And you can look at practical use cases with multiple examples and exercises. And then there's a practice and quiz, which we'll do in the next day tour. Thanks for listening.